sequence and series. And then we are supposed to do this in the next 3 weeks. So we're going to do this in 3 weeks. What are the things that we're supposed to cover? We are supposed to check number patterns, including arithmetic, also known as linear. We're also going to look at geometric sequence. And then number patterns, basically we are talking about the one that we were doing last year, the one of quadratic patterns. And then the other thing that we're going to look at is sigma notation. What we want to do here is to check if we have done it, yes or no. So each and every time when we finish a topic, we'll just tick to say, yes, it was done or it was not done. And then we have the following formulas to calculate the sum. If we want to calculate the sum of something, this one we use it when we want to calculate the sum of an arithmetic. And then this one we use it when we want to calculate the sum of a geometric sequence. Now, the other thing that you need to know about this is that we need to know how to derive these formulas. And then we need to know how to use them in applications, real life applications. You need to know how did we get to this formula here. There's 4 marks or 5 marks of knowing how to get to this formula here. So we'll get into that. We also need to know how to do this one. Something that we shouldn't worry about. And then we're also going to calculate sum to infinity. You've seen this thing before, it's infinity. So we have to know how to calculate the sum to infinity. Now, first example. Here's what we need to understand. Our sequence or patterns that we're going to have, they can either fall in these categories. You can either have something which is arithmetic. If it's not arithmetic, it can be geometric. If it's not geometric, it can also be quadratic. If it's not quadratic, then it can either be a combination of any of these 3. Those are the patterns or sequences that we're going to be dealing with. There's not any other one. It's either you have a quadratic. If you don't have a quadratic, you have an arithmetic. Arithmetic is also linear, by the way. Let's just remember that. It's just now we're in grade 12. We no longer call it linear. We're going to call it arithmetic, but it's still exactly the same thing. And then we have this one of a geometric. Now, let's just remind each other, how did we get a quadratic? Let's start with a quadratic. How did you get a quadratic pattern from last year? We checked the first difference. Quadratic. We check the first difference. We check the first difference and the second difference. So if we subtract, we started from, let's call this one term number 1. Let's call this one term number 2, term number 3. And then this one is term number 4. And then the strategy that we approached last year, we said we're going to start from term number 4, moving backwards. Okay? So if we say this one, subtract this one, we'll have 11 minus 6. What is 11 minus 6? 4. It's 5. And then we'll have 6. 6 minus 3. It's 3. And then we have 3 minus 2. What is 3 minus 2? It's 1. Can this be a linear pattern? Is it possible for it to be linear? Why can it not be linear? The first difference is not common again. So that's what we're going to check first. If the first difference is not common, then we go to the second one. Let's try to check the second one. Check the second difference. If we check the second difference, this one subtract this one. This one subtract this one. So 5 minus 3. What is 5 minus 3? It's 2. 3 minus 1. It's 2. No? So what kind of a pattern is this one? So this one, it makes it to be what? A quadratic. Now, as soon as you know quadratic, then you can determine the next 2 terms. It's going to be simple. As soon as you know what kind of a pattern it is, then you can determine the next 2 terms. So how did we do it? We said if we add this one plus this one plus this one, they're going to give us the next term. So what is 11 plus 5 plus 2? We get 18. So we say we have 18. After that, we say 18 minus 11. What is 18 minus 11? Okay, we get 7. Okay. So here we get 7. And then we say 7 minus 5. We get what? 2. Okay, sure. And then after that, if we add 18 plus 7 plus 2, it gives us the next term again. So this one plus this one, it gives us what? 27. Then we'll get a mark for this one and a mark for this one. Okay, let's check the next one. Here. First, we check the first difference. Okay, we have 16 minus 13. What is 16 minus 13? It's 3. 13 minus 10? It's 3. 10 minus 7? It's 3. Okay, what kind of a pattern is this one? Okay, this one, it's linear. Now, if it's linear, for us to get the next term, we'll just add these 2. So if I add these 2, it says 16 plus 3. So I have 19. And then 19 plus 3 is 21. Then you get 1 mark here, and then you also get 1 mark here. 22. There's someone who lied. Okay, it's 22. Sure. Okay, let's check the third one. What's happening here? Check the first difference again. That's where we usually start. Okay, if we say from the term number 4, if we say 48 minus 24, what do we get? Okay, we get 24 for this one. Yeah? And then if we say this one, subtract this one, what do we get? Okay, this one we get 12. And then this one, subtract this one, we get 6. Can it be linear? It can be linear, okay. So let's check the next one then. If it can be quadratic. So if you say this one, subtract this one, it's 12. No? This one, subtract this one, it's 6. Can it be quadratic? So it's not linear, it's not quadratic. So we're introducing the new one that we spoke about. Let's try to check if it can be geometric. A geometric series or a sequence. You see it by having a ratio. Now, how do you get the ratio? You get it by saying term number 2 divided by term number 1 should be equaling to term number 3 divided by term number 2. This should also be equaling to term number 4 divided by term number 3. So basically, what am I saying here? I'm saying which I'm going to say 48 divided by 24. And then if I divide these two and then they give me the same as 24 divided by 12, then this thing here is geometric. Let's check that. If you say 48 divided by, so unlike before, I agree before we're subtracting, so we're dividing here, 48 divided by 24. What is 48 divided by 24? 48 divided by 2, by 24 is 2. No? So we have 48 divided by 24, it gives us 2. No? So we write put here, we have 2. Try this one then. Say 24 divided by 12. It's 2. No? And then say 12 divided by 6. Now the ratio is constant. If the ratio is constant, then it makes it to be geometric. It's not geometric if the ratio is not constant. So we can only have a geometric if the ratio is constant. Now, basically on a geometric, how does it work? For me to go from term number 1 to term number 2, I'm going to multiply with this ratio here. For example, I said 6 multiplied by 2. What is 6 multiplied by 2? And then 12 multiplied by 2 is what? 24 multiplied by 2 is what? 48 multiplied by 2 is 96. So that's how I get the next term. 98 multiplied. Here we're multiplying. Now, what did we do last year? We added. For me to go from here to here, we said plus 3. For me to go from here to here, we said what? Plus 3. And then here, on this one, we said, for me to go from here to here, I needed to add this one plus this one plus this one, then they will give me this one. Here, with geometric, we multiply. So if we say 2 multiplied by 96, what do you get? 192. Okay, so we write which here we have 192. So you get your 2 marks. So we have linear, we have quadratic, and then we can also have what? A geometry. What happens? Let's look at this one then. So all in all, your steps are simple. If you want to, if you are given a pattern and then they say write down the next 2 terms, first thing first, you have to check if the pattern has a common difference. If doesn't have a common difference, to check if we have a second common difference. And then if it has a second common difference, then it makes it to be what? To be a quadratic. But now, if you check and then it doesn't have a second common difference, it means which you can go and check if it's geometric. Now let's check number 3 or number 4. If we look at this pattern here. Now, check if it's linear. How do you check if it's linear? Check first difference again. Okay, let's check the first difference. This one, subtract this one. 12 minus 15, what do you get? It's minus 3. Okay. 15 minus 6. It's 9. Sharp. 6 minus 9. Minus 3. Okay. This one, subtract this one. It's 6. And then this one, subtract this one. It's 0. Can it be linear? It can be linear. Okay, let's try something else then. If it can be linear, we move on. This one, subtract this one. Check if it can be quadratic. Minus 3 minus 9. So you're going to have minus 3 minus 9. What is minus 3 minus 9? Minus 12. Okay. 9 minus 3. So here you have 9. Let's show you how to type it in your calculator. So you have something that looks like this. You have 9 again. Minus, open bracket, minus 3. And then what do you get? 12. Okay, we get 12. And then 12 and minus 12, they are not the same. 12 and minus 12, they are not the same. So already we can see it's not quadratic. We shouldn't waste our time. First two, they just have to be the same. If they're not the same, it's not quadratic. What happens if this one then becomes the same? It doesn't matter. As long as we have one of them which is not the same, it means which is not quadratic. We want all of them to be the same. Does it make sense? Okay, if it's not linear, it's not quadratic, what else did we check? Ratio. Okay? Let's check the ratio. And then you just have to check the first two or the last two. It doesn't matter. If it doesn't work that one, you move on to the next one. Okay, let's say 12 divided by 15. If I say 12 divided by 15, I get what? 4 all over 5. No? Okay, sharp. And then we say 15 divided by 6. 15 divided by 6, what do you get? 5 all over 2. Is this one and this one the same? They're not the same. So we know something. It's not linear. It's not quadratic. It's also not what? Geometric. So if it's not any of this, we said, what are we going to check now? We're going to check what? If it can be a combination of any of these three. There's no any other pattern that we're going to be doing in grade 12. We're going to be doing a combination, or we're going to do number 1, linear, quadratic, geometric. So what you do, you're going to split this thing here. Positions, you're going to split the positions. You have the odd positions. Odd positions, it's your 1, it's your 3, it's your 5. Yeah? So we're going to group those together. Let me show you what do I mean by that. So I have something like this. So I'm going to call this one term number 1. I skip term number 2 because it's an even position. I skip that one. I go to term number 3. No? And then after that, I go to term number what? Term number 5. And then I take out these ones. If I take out these ones, let's check what am I going to have. We have 3 again. And then after 3, what do we have? We have 9. After 9, we have what? 15. Okay, sharp. After that, I'm going to take out the even position. Even position is what? It's term number 2 again. And then it's term number what? Number 4. And then it's term number 6. We're still fine again. Take out those ones. If you take out those ones, what do you have? You have 3 again. And then you have what? 6. And then you have what? 12. Okay, now let's check these ones. The green color. We're going to check the green color. With what kind of a pattern do they form? Green, let's check. If I say 15 minus 9, what is 15 minus 9? It's a 6. 9 minus 3. And then we said this one subtract this one, we got 6. So we said this is linear. Now, what is going to be the next term if it's linear? Obvious, if you say this one plus this one. So the next term that is going to follow, it's going to be term number 7. Term number 7 comes from what? From the linear pattern. I agree, we're determining the next 2 terms. So term number 7 is going to come from the linear. Term number 8 is going to come from this other one that we don't know. We're still going to check what kind of a pattern it is. So if I say 15 plus 6, what is 15 plus 6? This is going to be 21. So I come and write with this one here is 21. It's fine. Okay, let's check this one then. If we check if it can be linear, you say this one, subtract this one. 12 minus 6, you got what? 6. And then you say 6 minus 3. 6 minus 3, what do you get? You get 3. Is it linear? It's not linear. Okay, let's check. This one, subtract this one. It's 3. We can't compare it with anyone else, so it can't be quadratic. We don't know which it can be quadratic. For it to be quadratic, we need to compare it with someone else. So you only have 3. 3, you compare it with who? There's no one. Here, actually, we had 6. We compare it with 6. 6 and 6, because they're equal, then actually what to it. Now, if it's not that, then what are we going to do then? We're going to check if it can be geometric. We check if it can be geometric. We say we say 12 divided by 6. What is 12 divided by 6? Is what? It's 2. 6 divided by 3. It's 2. Now 2 is equivalent to 2. Right? Since 2 is equivalent to 2, it makes it to be what? Geometric. And then if it's geometric, it means for us to go from here to here, we said multiplied by 2. For us to go from here to here, we said what? Multiplied by 2. So 2 multiplied by 12. What is going to be 2 multiplied by 12? It's 24. So our next term here is going to be what? 24. And then we are officially done here. The other thing that I did for you now is to make sure this information is there. So I'll just send you this worksheet with all the solutions. I can send you the worksheet without the solutions. So here I try to make sure when I write this thing, I tell you the steps that you need to follow to say, okay, check the common ratio. These are the steps that you have to follow. And then we're going to do our activity now. Yeah, activity here, it also has the solutions here, our activity. So let's do the activity. Yes, what?